Waiting to go live. And we're good. I think. Yeah, there we go. Hey, Hacksters! Welcome to Tuesday. It is officially Tiny Tuesday now. I was doing Teardown Tuesday, and I'm still working up to that, but I figure that falls under Tiny as well. Anyway, so, I have been planning to do this thing for a long time called Mini Meaties, which is a small version of Archimedes, my robot owl, but somebody beat me to it. But I'm still going to do it because they're going to be different, and that's the wonderful thing about making, is that you can always do your own spin on something and it'll add extra awesomeness to the world. So, this is partly spurred by the fact that my friend Odd Jayy created this kid's version of his recent Odin project. We did an interview, it's a really quick one, in LA about this guy. It's a crowbot, another one in the series of companion bots that we've been building. So last year for Maker Faire, I created Archimedes, the robot owl, which is the one I'm going to show you. He's been building these spiders. He's got more plans for other animals, and I guess I'm sticking with birds for now. But yeah, so the whole idea is that he's making a very simplified version for children to be able to build. And it's still based, I think, on an Arduino Nano. Or a native fruit trinket, I lied, and has a micro servo and has a bunch of like cool 3D printed parts. And this is it with his nephew, it's so cute! Ah! Anyway, so you can check that out on Hackster now. But this is basically kicking my butt into gear to finish my own project and publish it. I haven't even published Archimedes 2 yet, which is an upgrade on my previous robot. And I wanted to go through some of the ways that you upgrade these things. So for example, the new one is much lighter due to a larger number of 3D printed parts instead of these sort of custom metal brackets you have to find for the servos to mount to. I decided to attach it with a GoPro mount because that makes it much easier to swap out different shoulder mounts. And it sits on your shoulder instead of, and uses an elastic harness, instead of the previous version which used this whole huge assembly of like bike inner tubes with armature wire running through it and stuff like that. Plus I've switched out his brain. And the main difference for usability is the wings. So these ones on the right are mounted on zip ties, which work as flexible hinges, so that he can bounce a little bit. It's not actuated, there's no motors on the wings, but he can still like move around a little bit and be a little bit more lifelike. He does actually move. It's very warm here, so I apologize for how shiny I am. Call it the glow. There we go. Yeah, he's still got this same sort of basic animation, which hasn't changed much from the first one, but he's going to show more emotions through these like colors and stuff. I also went with some more interesting materials, like these iridescent CDs that I used for the original one's beak. And that's still on the new one, but he also has little wing accents as well. So yeah, some aesthetic upgrades. His eyes are now LEDs filtered through moonstones. So we've got a little bit of gem action there. But otherwise, he's mostly the same. So what I want to do with this new one is basically make a mini Medes or a micro Medes that will be lighter, more like easier to pack for traveling, so that it won't get all janked up, to use a technical term, and also that it will be much easier for kids. Now, what I want to do with this is, since the microbit, the BBC microbit is this board that was designed by a bunch of companies and given away to an entire generation of school kids in the UK. And it has this 5x5 LED grid. They're all red LEDs, but it does have a little blue thing there. You've got these two little buttons here. You've got 5 big pins broken out, including 3 GPIOs, 3 volts and ground. You've got all these sensors, including an audio level sensor, you've got an accelerometer, you've got Bluetooth low energy so they can communicate with each other as well as other stuff. That's going to become a big part of this, as I will show you in a moment. And also a lithium polymer battery connector for a rechargeable battery so that it can run sort of on its own and it'll charge it over USB when you have it plugged in, and then you can just pull it off. I have some other nefarious plans for this as well, but oh, there's so much going on. I can't get to it all. There's also a compass or a magnetometer. What else? Processor. Yeah, everything's like labeled on it, so it's very cute and cool. And then also, the rest of these are also GPIO pins, which means that it can kind of grow with you. Anyway, so I want, since this is a board that's designed for children and to grow with them, I want this to be the basis of my Mini-Midi's companion robot. I think that it will be extremely well suited to that. And another person that I had on the show recently, Helen Leigh, showed us her beautiful Mini-Moo gloves, which are her smaller version, or kid-friendly version, of the Mimu gloves that Imogen Heap uses, which are amazing. They're like sensor gloves that you use to control music, like Ableton Live and stuff like that. So cool! I've seen her use them live. It was amazing. But anyway, so there's this version for which Helen designed a speaker for the microbit, which can be hooked up and has an actual, like, serious, you know, chunky speaker on here, which can really pump out some jams. And so I've had a really difficult time getting sound integration with any controller that I've been trying to do with Archimedes, and so this may actually be the first one that has significant audio interaction, and that will make you very happy. So these together are very small, and they run off of very little power, and they can easily tuck inside of a little robot. So what we're going to do is talk about some of the new design things and hopefully get to it a little bit as well. So the new robot, Archimedes is designed to be kind of like cool, I guess, or wise looking. He's got a little bit of attitude. He's kind of a diva, but he's got, you know, these eyebrows and stuff, and he's got his little top hat, very dapper. The new one is going to be rather sillier, and instead of an owl, it's going to be based on what I think is the silliest looking bird, one of the silliest ones, and it's called the tawny frogmouth. It's exactly what it sounds like. It's a brown bird with a big mouth, and it's got these ridiculous wide-set eyes that make it look incredibly silly. It's like, if you've seen The Dark Crystal, it's like the Fizzgig of birds. And they have these incredibly emotive faces, which I may not be able to capture, but look what they do with their mouths. It's so hilarious and cute. So I want to make a robot based on this, and it will not be elegant. It will be very silly and friendly for the little ones. I just want to look at this forever. Also, the baby ones are even more ridiculous looking. Like, look at this. Is this not a Muppet come to life? This is totally a Muppet. So, in order to design this new one, I want to actually bring you all through the process with me, because I think it's a great opportunity while I'm building something new from scratch. There's also some great videos of these things on YouTube. Including this guy who sort of sticks his finger in their mouths to demonstrate how they're very, I don't know, sort of friendly, I guess? I don't know. So one of the main things that I'm going to be doing over the next few weeks is using Tinkercad, as I usually do, to mash up 3D models together. For designing stuff from scratch, I'll typically use onshape.com, which is another browser-based 3D CAD modeling tool. And this one is much simpler. It's sort of like the Tinker Toys, hence Tinkercad, of 3D modeling. And I use it, for example, when I pull GoPro brackets off of Thingiverse, which is a great resource for finding 3D models. You can download the STLs, and then import them into Tinkercad and be able to mash them up with whatever random shapes you want to create, which is super awesome. It's what I used in a couple of other instances as well to produce, I don't know, to modify, for example, an STL that comes with a robot kit. You can upgrade your auto robot to be a cat instead of just a robot. This isn't loading because my computer's freaking out. But yeah, other things like that, you know, just personalize and redesign existing designs, which is really great. Thingiverse is that site that I was talking about where you can pull STLs like, for example, just search for GoPro mount or even GoPro. And you'll find, for example, a brass knuckles that can hold your GoPro. Only it's PLA probably or something like that. And then you can mash that up, for example, with a microbit holder. So there's all kinds of stuff people have designed for the microbit as well. And if you're going to be using any of these, obviously you want to link to the original design and credit the original creator in your project. Very important. We've been, yeah. It's so important to credit people that you are using stuff from. We've had a couple of incidents in the contest that we do not want to repeat, so please make sure that you do that. Yeah, so what I'm going to be doing is grabbing that same GoPro servo bracket, but using it to create a much smaller mount for much smaller servos. So in the past I've used these pretty big, beefy servos. Tower Pro MG996R or something like that. MG996R Tower Pro, yeah. So those are quite large. As you can see here, it's sort of this entire big block. And it's quite heavy. And for a smaller child size and child weight robot, I want to use these guys instead. And also I've been deciding how to upgrade it so that it will actually flap its wings mechanically instead of having to just passively bounce up and down. It'll actively flap. And today I finally figured that out. I'm just going to use these little rubber guys and attach them to the horns of this servo, and then attach the other sides to hooks on the insides of the wings, and have the wings mounted again on these flexible hinges, which will hold them sort of up. So the wing will be up. Pretend this is, yeah, this is the wing. Okay. My left hand is the wing. It's pivoting on this zip tie here, and it's held in place by this rubber band. So when the servo arm rotates, it'll pull on the rubber band and pull the wing down. And it'll do that for both sides at the same time. So it'll be this sort of like two flexible elastic things working against each other. This hinge wants to pull it up, and then this rubber band will pull it down. And that way you have a lot of durability and flexibility in the system, which will make it easy to pack. Yay! Because these things go everywhere. And also, when you're building something for kids to interact with, then it's going to be a little bit more challenging to make sure that nothing breaks. Because they like to explore, which is great. Now, the final piece of this puzzle is how to actually control it. And I want to make a mystical experience. Well, first up, it would be fun to just repurpose the Mini Moo glove to provide sort of like, it would look kind of like a falconer's gauntlet, but when you moved your hand, it would control the robot to move. However, I realized that kids are going to want to try this out, and what's going to be easier is if I make an orb that I can just use to move the robot and then hand it to them, and they can control the robot themselves, because I think everyone's going to love that, you know? Even if I'm wearing it, they can still control it. So this is just a capsule machine gotcha ball with some foam in it that's going to be used to hold the microbit. In fact, I have an example of a similar concept that I'm building for a separate project. It's just got like a lithium polymer battery, a power switch, very important, and that's attached to this microbit here. Let's see if that'll actually do anything. Yeah. So this is actually part of this project that I'm demonstrating here, the bikey face emoji tail light, where it shows a heart unless the other microbit... Oh, you know what? Why don't I just demonstrate this? I'm kind of giving away what the other project is going to be, but basically this one sits on the back of the bike, this one sits on the front of the bike, and then you push these and you get turn signals and stop signal on your bike. But I'm repurposing them because I don't have a million of these microbits, and what it's going to happen instead is that one of them is going to be a controller in an orb, so that when you rotate it, it's going to move the robot. And this is because they can communicate with each other over Bluetooth. So that's very exciting. Bluetooth low energy, that is. So those are the plans, and it's 6:05 and I kind of have to get going soon, but I would like to first just maybe walk through a little bit of how I'm going to start doing this in Tinkercad. Because my first thing that I'm going to want to do, well actually maybe I should build the, make sure I can program the things first. No, let's do the Tinkercad. Okay, so what I'm going to do is open up a new design, or actually I might just mod an existing one. Duplicate these guys. I think my computer also does not like this heat. Unfortunately, it can't take a drink of water. Let's see if there's any questions, actually. Someone says, oh yeah, Jay says, he's here to inspire. Yes, you are, Jay. Jawad says, oops, I don't have a 3D printer. Well, actually, if you don't have a 3D printer, you can still use 3D printed parts in your robot. I've actually done this. Okay, so this is a tool that I constantly recommend to friends if they don't have a 3D printer, or if they're on a tight schedule and they just can't take the time to make sure that a print comes out perfectly, or if they want to do a material that they don't have, or any other concerns like that. For example, I've used this service. Basically, it's sort of a peer-to-peer 3D printing service. You used to be able to choose who would print your part, but you can't anymore. However, yeah, basically you upload your part, you choose what materials to use, what resolution and where you want it to be fabbed, and then they have people all over the world, a community of people doing 3D printing, who will produce your part. And in order to get on the roster, they have to, for example, prove that they can print and produce a part with sufficient quality. So you know that it's going to be good, and in fact, since you're paying them, you pay this person to produce the part for you, then it's sort of their job to make sure that it's good. But also, if you have a 3D printer, you can make some extra money this way, and if you're using the service, you get to feel good about supporting fellow makers, which is pretty cool. So for example, I had to go on a business trip somewhere. I didn't have time to 3D print a part before I left. In fact, I think I was still tweaking it in the airport, but I was able to get it printed in my destination city and then go and pick it up before the event. In fact, I might have had it delivered to the hotel. And so for weird situations like that, where you really need a part and you need it in some weird material or just super fast or whatever, 3D Hubs is fantastic, and I highly recommend it. I've had a ton of other friends use it as well and really, really enjoyed it. So yeah, 3D Hubs, super good tool. I may not actually have time to get into the Tinkercad part of this. I got really excited about 3D Hubs. But just check out all the wonderful things people are producing for this. Look at this little angry guy up here. I mean, obviously I love it partly because of the color, but it's not just that. Look at this little angry face. And that's kind of what I want this Tawny Frogmouth bot to look like. Just like this, it's just really adorable little thing. People have told me I should do the eyebrows as well and make those move because it could emote better. I think it's going to be really hard though. But yeah, so this one will basically be able to swivel its head and then also move its wings in and out to flap them. So yeah, let's just get started with this. Where do I want to start actually? Yeah, this is going to be the base servo, and basically I'm going to need to This is gonna be, this model is getting kind of complex because I've modded it a bunch of times before, but I don't really care. I'm just gonna keep playing with the same one because it's easy. The way that Tinkercad works is kind of different from a lot of other CAD tools. So instead of sort of sketching things and then extruding them, you do this thing where you create objects and then you group them. So those objects can be solids or holes. So you're either adding or subtracting material with each shape that you add, which restricts you somewhat, and it does mean that it can be harder to get precisely what you want. But if I hide myself here, you can see that you can edit the grid, for example, so you can get more precision, which is really nice. And it's quite usable for things like this. So now I have my little GoPro base here, which is kind of optimized for a little bit of strength. And also, at least in the previous version of Archimedes, the servo was offset to the side because of how it's mounted. Let's see if I can show you here. So it'd be easier on the other one. Where is he? Okay. Since the servo arm is sort of on the side here, I don't know if you can see that, it needs to be offset on the base in order that the robot will actually be centered. If you see this, the GoPro is there, and the arm comes out sort of further that way, so that the whole robot sits over the base. And balance is a big part of this, especially when you're making something body-mounted. If it's just going to sit on a table, you can make a big flat base and weight it down and stuff, and it'll sit in one spot. But if you're strapping it to yourself, you don't really have that option. And also holding it on your shoulder is going to get tiring after a while. So the next thing that I want to do is, where was I? Oh yeah, find a good microbit base and mash that up with it. I've seen a really nice one before. Because I want this bottom part to hold both the microbit and the bottom servo. There may not be a super great one for exactly what I want. Wait, what? Someone's got a servo plus microbit mount? Oh. Oh, they like made a robot out of a milk carton with it. And I don't think that this is actually attached to the microbit. I think this is like a milk cap that they printed that will attach to a servo or something like that. Oh wait, no, they printed something that attaches the servo to the cap. Interesting. Well, I'm still on my quest to find a good microbit holder that suits my needs. This one looks interesting. I don't know if it's actually going to load, unfortunately. Yeah, here we go. So you can see on this one that they have these 5 screws at the bottom, which, what's on the back there? I don't know, but those may also be providing electronic connections as well as mechanical ones, which is pretty cool. I like that idea. So this is a great place to come for kind of inspiration as well as STLs. What I'm looking for is something specifically that holds it from the bottom and holds it straight. I could model something from scratch, but I think this will be much easier. And now we come to another question, actually. Do I want to hold it straight up or do I want to hold it upside down? Because if I hold it straight up, I can take advantage of the pre-existing animations that have been programmed for it, which makes things a lot easier. But that means that the USB cable is coming out of the top. Now if I put it like this, then the cable will come out the bottom. That'll be much easier for making it stable and stuff. It's a solid question. It's one thing that I will have to ponder. And then I basically want the whole mount to have a GoPro mount on the bottom to hold the microbit in some orientation. I think it'll go this way actually, because the servo wants to have its cable come out the top as well, or else it's mounted really low, which doesn't make sense for these wings. So I think it'll go like this. And just to visualize, I don't want the... I'll have to trim the horns because I don't want them getting caught on the cable, and I obviously don't want them to interfere with the battery either. We've got a lot of noise coming from upstairs, sorry. Let's continue our quest. Oh, this one allows you to more easily attach to it with crocodile clips. That could be a good idea, actually. You know what? I probably don't want to require children to solder. I have these servos that have 3 pins, and I can attach headers, or use headers to poke into those. What I need is like a little servo to microbit converter, and figuring out how to connect these guys to those guys is going to be a little bit of a chore. The other thing I need to figure out is actually, does the microbit have 2 PWM pins that I can use to control the servo? Let's find out. And at least in the past, the radio stuff was only accessible from the Mu editor, which is a MicroPython editor for writing Python that interfaces with this microcontroller. However, I think that might have changed. So let's see. Pulse width modulation. Oh, you know what? I know that at least 2 of the pins can do it because I used them for neopixels on my skateboard. Neopixels are these PWM controlled light red, green, blue RGB LED strips. Cool, okay. So this is the MicroPython documentation, by the way. It's microbit-micropython.readthedocs.io. Excellent. And what did that other thing say? Ooh, Kitronic has a microbit to servo tutorial. Fantastic. Oh, they have a breakout board specifically for that. I don't want a special breakout board for that. Someone published something about this on April 1st, 2018, so hopefully it's not a joke. Nice! This one does not have any extra stuff, and it uses Microsoft MakeCode. Fantastic! That's great! Oh, they're using the same servos, the giant ones that I was using for the previous version of Archimedes. Wait, that's not what that is. That's a tiny one. That's a microservo. Whatever. But cool. They're telling us how to do it with pin 0. Let's see if I can just get this running right now. So this is going to be the one on the actual robot, and I'm going to find some alligator clips, hopefully, or else just solder to this board, which would be less cool. What if I use... Ooh. What if I use hardware? Okay, so 1 second, I'm going to come back in a moment. Oh no. Sorry for the vanishing video there. It did a weird thing. I hope that wasn't there for long. Looks like we're okay. Hatham says, or just use Fusion 360 since it gives you a 3-year free trial. I would, but my 3-year free trial ended long ago, and I need to sign up for another one. I would rather use something that maybe is a little limited but doesn't expire. Just so that I don't use, like right now it's a really huge pain to go back and get access to my old models that were saved in Fusion 360. It's much better for me if I can easily go grab them. Onshape's limitations are that if it's free, if you're using the free version, then all your models are publicly accessible. And Tinkercad is free completely, but it has a few other limitations. So what I'm going to do is I've got some various sizes and shapes of hardware here. These wing nuts are not going to do the job because they will bridge over to other pins. These ones are too long. We've got some nylon standoffs. And we do have what looks like some nice little screws with corresponding nuts. Fantastic. Oh no! Come back. And standoffs. Ooh, that's cool. So let's see if I can screw some connections onto these. I have 3 nuts, that's perfect. Those might actually go through the holes though. Let's see. Just barely not. Okay, that's exactly the size I want, in fact. Not big enough to hit the other pins, but just big enough to not go through the holes. So I'm gonna basically create my own screw terminals here. And I might end up soldering or epoxying these screws to the back. Oh no, the screw goes through. Well, wait, we've got these standoffs that we can use. I wonder what these are from. This is sort of the box where I throw all the random stuff that I accrue over the course of building stuff and having extras. So here we go. Our little ground terminal. And I would want to epoxy this in place so it doesn't slide around like that. See how that can still hit other pins? Suboptimal. It's actually not even that bad right now. But yeah. So here we go. Number 2. Our 3-volt pin. Now I'll probably want to control or power the servos with a separate power supply, both because 5 volts will give them the juice they need. I should check out actually how much power these ones want because I don't want to fry them. But also if I'm running 2 servos, I'm certain that the microbit is not going to like it. It's going to be a lot of amps for its tiny little power system. And the last one. I might actually just strip these servo wires and then wrap them around the screw terminal. I think this is pretty kid-friendly. It's a little fiddly, but it's still pretty kid-friendly. I'm going to go with pin 0 since that's what's in the tutorial. Alright, cool. So now we have our DIY screw terminals. I'm going to chop this off. And actually what I think I'm going to do is create my own little ring terminals for these. They won't be very strong though. Not very durable. So maybe I'll just strip them for now, then I don't have to solder everything and it'll be much faster. Ooh, another thing I could do is attach headers to this. And I really want to, as always, hook up the circuit before I assemble everything because I need to calibrate these servos before I create the finished robot. I need to know where 90 degrees is before assembling the whole thing, or else I'm going to have to deassemble it and reassemble it unless I get some magical luck. Oh, you know what? These need to be a little longer. Let's go with that. Okay. So that my brown wire here is ground. I'm going to curve it around a little bit. And then just sort of, ooh, loosen this up a little bit and hook it in there. I really should get going, but I also really want to get this this tested tonight. I'll have to do the radio control a bit later, though, I think. But this is part one, where we get the wires hooked up and get it to control the servo. Oh, I see. I'm gonna have to put this between the standoff and the screw, just because that big hole makes things more awkward. Don't quote me on that. Sorry. I'm blaming the heat for any verbal slip-ups. Stop doing that! It's always advantageous to talk to your circuits. There we go. Oh, and I can kind of hold that clamped together with my thumb while I tighten the nut down. And you know, I could use a screwdriver here, but okay, I'm gonna do it. I was gonna say I'm too lazy, but I'm also too lazy to keep poking at that with my finger. In fact, I probably should have wrapped it the other way around the screw so that when I tighten it, it naturally pulls the wire in instead of vice versa. There we go. Okay, now that's going to be fairly likely to snap unless I reinforce it somehow. So once I have it nice the way that I want it, I'm going to probably put some epoxy or hot glue over that, which will help insulate the connection as well as stabilizing it physically. All right, let's bend this guy. How's everyone else doing? I don't know about you, but I'm melting. Tried opening the window and it got warmer. It's like my nightmare. Living in a nightmare. Yeah. There we go. Oh no, I was going to do it the other way. So if I wrap this wire around this way, then see how when I rotate the screw to the right, it's going to pull that wire in instead of pushing it out? Science. Not very dexterous science. I mean, that's the idea anyway. If I had more precise fingers, it would work that way. Boom. Right now my main concern is just to make sure these don't short each other out or short out to other pins. That looks good. Yeah. Okay, so those are pretty stable. Last one. Curve it around. Unscrew the screw a little bit. Put it in. Stay on screen. I'd say our camera person is off today, but we don't have a camera person, it's just me. Ah! Cool. All right, so now we have that connected. Let's hook this up to my computer and get the... Where's the micro USB cable? Oh no! Where's the micro USB? Oh, I know I've got one in here. Oh yeah, the red one from Helen's kit. Fantastic. Okay. So let's keep everything from shorting out via the pliers. And my screwdriver. It's officially 6:30. I'm kind of late already. Oh well, I think it's fine. Actually, it took less time to get to the place than I expected last time. So now we have this going on. We have a connection. We have the servo. I'll put this little servo horn onto here. And I'm going to open up the example code from that tutorial that I just found on Hackster, which I will link in the description of this video after I wrap up here. So we've got our things connected to ground, 3 volts, and pin 0. We're going to check out the sketch. Get code here. Yes. The nice thing about Microsoft Make Code is that you can edit it either in block code, like Blockly or Scratch or whatever, or in JavaScript, and you can toggle back and forth between the two, which is part of why I say that this whole system grows with you. And it's perfect for kids to learn with, yay! Whether they're like 5 years old or 15 or, 35, no matter what, you can all use this system to learn and sort of level up. It's very exciting. It's finally cooling down a little bit, so I finally have like a little bit more energy. Here we go. So forever, so this is going to loop forever. You're going to write pin 0 to 45. So a servo typically can go between 0 and 180 degrees. So this is basically a test loop that puts it to 45 degrees, 90 degrees, and 180 degrees. I'm going to say 30. And 150, because often what will happen with these little cheap servos is that it won't be able to actually go the entire way from 0 to 180, and instead it will freak out a little bit if you try to do that. So what I'm going to do now is move this up so you can see what I'm doing. Wait, servo test. Yes. Just save that and download it. Oh, and then the pause statements are in milliseconds, so that it's going to wait 1,000 milliseconds or 1 second between each step of that. So it's going to go to 30 degrees, wait a second, to 90 degrees, wait a second, and then like to 150 degrees and wait a second. And it's going to repeat that forever. Download. I think it might have already saved it to my computer, in fact. Let's see if the microbit shows up. Yes, good. You can't see this, but it's showing up on my computer as microbit in all caps as a USB flash drive. So all I have to do is take the .hex file that downloads now. Wow! And it's just exactly how it describes it here on the screen. I'm going to drop that onto my microbit flash drive looking thing. And then it's going to, it's flashing. It's literally flashing as it flashes it. And then my computer, which is a Mac, is going to complain that I've ejected the drive without, or I've removed the drive without ejecting it, because it always does that. Because I think it does that when the microbit resets itself. The computer is like, why did you unplug that thing? You didn't tell me you were going to unplug it. I'm mad now. Ooh, now see, nothing is really happening yet. I feel it moving, but it's not doing anything. And I wonder if that has to do with it not having enough power. Yeah, it's doing this little clicking noise. So what I'm going to try to do, really quick, because I do have to run away, But I want to try really quick giving it a different power source, and I'll show you how to do that really quick. Okay, 1 sec. Alright, so I happen to have this 5-volt battery from SparkFun, which got smashed somehow and conked out. So I'm stripping these 2 wires, white and black. And what I'm going to do is unscrew, well, I should unplug the entire assembly first. Then I'm going to grab my little tools to change around these screw terminals. I'm going to leave the data and ground lines connected, but I'm going to disconnect the power line and I guess tighten that down again just so it doesn't flop all over the place and bridge stuff. Okay, so now we have ground and data connected, and what I want to do is twist this power together and connect this ground into there. We basically need a common ground in order for the power to flow. All the grounds must be connected. Come here. There we go. Okay, so I'm gonna bend this little guy around, strip that a little more actually. This is my power cable, it's gonna go to the battery. Okay, I'm gonna curve that around, stick it in that same little crevice here. I might need to loosen it a little bit. No! Power came detached. Wait, no it didn't. Okay. Oh yeah, it did. That's fine. We'll fix it in a second. Okay. This is why I prefer solder to pretty much any other prototyping method, but whatever. No! Ah, stay in there. Ah! Really not going to get to my thing on time, but that's fine. Eighth time's the charm, right? That's what we say? Okay, cool. And because I can't leave well enough alone, I'll tighten it some more. There we go. No, I really can't, can I? Now it's detached. Ah, I'm the worst! Sorry you have to watch me fiddling around with this so much. I called it though. I was so like, this is gonna make it detach, and then it did. That doesn't actually mean that I'm good at what I do. I mean, I am, but not because I have any restraint when I can tell I'm doing the wrong thing. Boy. No! Stay in there! I'm just gonna stick it down the standoff, same as the other one's doing. Now they've both come off. Fantastic. Spectacular. Okay. We're gonna take both of these and cram them down into the standoff here, which does run a risk of actually severing the thin wire, but I'm gonna run that risk because I'm in a hurry. Oh, it won't actually go down there, will it? Well, that's unfortunate. This one will. Nope. I'm gonna do this. Okay, it looks like these are both touching the ground now. Hey. Unfortunately, my pliers don't really grab it very well. All right, here we go. Okay, cool. We have connections. And now I'm going to hook up the power to the power. Again. Gonna twist these around each other. Mostly twist the little one around the big one. And then hook that over so they sort of stay together. All right, and then I plug the other end of the power cable into the battery. And then I'm gonna plug this in. In fact, I can do that now. Okay, so now, shoomp, and making sure I have the polarity right. This goes into the battery. And then I'm gonna turn the battery on. Ugh. More nothing. Oh, the ground came off. Ugh, I'm just gonna hold it there. Hey! Obviously my screw terminals need some work, but our servo is moving. Yay! Interesting. So this is interesting because it implies that the servo is turning the opposite way to what I expect. Because remember, it goes 45, 90, 150. Or no, it goes 30, 90, 150. So it's going 60 degrees, 60 degrees, and then all the way from 150 back to 30, which is 120 degrees. So its little short hops should be 60 degrees, and they're going to the left instead of the right, as I would expect. Which means that from 0 to 180 does not go clockwise, as I would expect, but instead counterclockwise, or anti-clockwise, depending on when you're from, where you're from. Alright, anyway, that concludes our tiny robot design session for today. I'm stoked to have the servo working. Thank you so much for who wrote this tutorial anyway. I'll have to give you a shout out. Yeah, so I've got this saved. I'm going to share it and download the link so that I have that. And because I think that it opened this in the same window as the tutorial. So Anish something or other wrote this tutorial. What is your name? Oh, the loading is so slow. Anish Ansari, thank you so much for publishing this tutorial. It's super helpful. I'm going to use it in my robot and credit you because that's what we do. Yeah. Super excited. Thank you for joining me. I'm going to check and see if there's any last questions on Facebook. Unfortunately, if you're watching on YouTube, I can't see what you're saying, so I'll have to check those later. Marcio says, thank you for that. Thank you for watching. Yeah, okay, cool. Catch everyone tomorrow. It will be Hackster Cafe Wednesday, so hopefully I'll have an interview out for you. Otherwise, we'll have something fun. I have a What the Wednesday up my sleeve for when we don't have anything on the docket. Catch you then. Ciao. Hack on.